Okay, let's go through the week 6 assessment here. Focus that a little better. Okay, let's sketch this graph here. We have this piecewise defined function. We've got x squared when x is greater than or equal to 2, and this line 2x minus 1 for x less than 2. Okay, so x squared we know is a parabola. Looks like this. Kind of dotted it in. I'm not going to keep the whole thing. We want to start at 2. So let's plug in 2. See what our starting y value will be. Of course, 2 squared is 4. So we're going to start here at the point 2, 4. And we want x greater than or equal to 2. So I'm going to keep the right half, this chunk right here. And none of this actually exists. Of course, the solid dot because of the equal to. Okay, so that is x squared for x greater than or equal to 2. Then we'll throw on top of here this line, y equals 2x minus 1. We've got a y-intercept at 0, negative 1. We got a slope of 2, so if I go over 1, up 2, I would hit another point here at the point 1, 1. So let's kind of dot that in. So here's my line. Again, we should see where our starting point is by plugging in 2. So 2 times 2 is 4, minus 1 would be 3. So over here at 2, we should be up 3. I think I kind of missed with my dotted line here. We should be a little more right there. Going down through here. Open circle because there's no equal to here. And I want to keep everything 2 to the left. X is less than 2. We're thinking left and right, not up and down. So that line, that chunk of the line I want will look like this. So here's my final graph. This chunk here for the quadratic, this chunk here for the line. Okay, next. We're graphing this guy, g of x, where our dividing spot here is at 3. Okay, I want absolute value of x minus 1. That's just absolute value of x scooted to the left 1, or sorry, to the right 1. I almost went the wrong way. Remember, inside a minus goes right. So we get something that looks roughly like this nice V shape. We're going to cut this guy off, though, at 3. So let's plug in a 3, see what our corresponding y value would be. 3 minus 1 is 2. Absolute value of 2 is 2. So over here at 3, we should be up at 2. Okay, solid dot because of the solid dot because of the equal to. I want to keep this for x is greater than 3. So that's the right side. Starting at 3, going to the right. So none of this is actually part of the final graph. That was just there to help me get started. Okay, then on top of that, x squared minus 1 we know is a parabola. Scooted down 1, so some kind of graph that'll look like this. As a rough sketch. We should see exactly what that y value is going to be at that boundary of 3. 3 squared is 9, minus 1 is 8. So over here at 3, 8, we'll have our open circle. And we get this parabola that looks like this. We're only keeping less than 3. Here's x equals 3 and less to the left. So we've got this open circle here at our corner, and that's where the graph switches from this parabola. At 3, we switch over and start using this absolute value. Okay, let's use this same function here and make sure we know how to evaluate piecewise defined functions. G of 1 means plug in x equals 1. We have to figure out which formula lets us use 1. This top formula we use for x is 3 and bigger. The bottom when x is less than 3. So g of 1, 1's less than 3, I would use the bottom formula. 1 squared minus 1, I think that's 0. G of 3, which category includes 3? The top one I use when x equals 3. So this would be absolute value of 3 minus 1. That's absolute value of 2. That's 2. G of negative 2, which category does negative 2 fall into? Negative 2 is less than 3, so I'll use the bottom formula. So I'll have negative 2 squared minus 1. See, that's 4 minus 1 is 3. G of 5, which category does 5 fall into? 5's bigger than 3, so I would use the top formula. Absolute value of 5 minus 1, absolute value of 4 is 4. Okay, our next page. Our directions say to solve all of these by factoring. This one, actually, we won't be able to solve by factoring. It's going to require a little more work. The rest of these will, though. Okay, if we're going to factor, we better have a 0 on one side. Otherwise, we're not allowed to factor. So we do here, we're in standard form for the equation. This factors x minus 3, x minus 5 equals 0. This is an equation. This one better also be an equation. We could check that real quick. X times x is x squared. X times negative 5 would be negative 5x. For the inners, negative 3x. And for the outers, positive 15. Okay, we know we got that one right and that one right. It's the middle one you really have to check. Negative 5x, negative 3x is negative 8x. Okay, so we have these two factors equal to 0. We set each one equal to 0. And solve. X minus 3 equals 0, so x equals 3. X minus 5 equals 0. X equals 5. We got two answers. Quadratics always have two answers. Okay, if we're going to solve this guy by factoring, we have to get it in standard form first. We have to get everything on one side equal to 0. Otherwise, we're not allowed to start factoring. Okay, this factors x minus 3, x minus 4 equal to 0. You can check that. 3 times 4, negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7. Set each factor equal to 0. Here, x minus 3 equals 0. We get x equals 3. X minus 4 equals 0, we get x equals 4. Okay, this next one, we want to solve by factoring. We actually have a common factor here of 2, so we could, and I will, divide everything, both sides, by 2, and get x squared minus 5x minus 6 equals 0. That factors x minus 6, x plus 1 equals 0. We could check that. Negative 6 times positive 1 is negative 6. Negative 6 plus 1 is negative 5. We get two factors. We set them both equal to 0. X minus 6 equals 0. Gives us x equals 6. X plus 1 equals 0 gives us x is negative 1. Positive 6 and negative 1. Okay, here, if we're going to try to solve this by factoring, we have to get it in standard form. So distribute. X squared minus 2x equals negative 24. Move everything to the other side. We have to be in standard form. We have to have a 0. equals 0. Okay, this won't factor. You can try everything you want. It's not going to factor. We're going to have to solve this some other method. So, quadratic formula, completing the square, whatever your favorite method is. I'll do quadratic formula here. Okay, so we get x is opposite of b plus or minus the square root of b squared. B is negative 2, so squared will be 4, minus 4 times a times c all over twice a. Okay, so what do we have inside here? We have 4 minus 4 times 1 times 24. Order of operations, we have to do this multiplication first. So 4 times 24 would be 96, I think. Let me check that real quick. 96, yes. So I'll get x is 2 plus or minus square root of 4 minus 96 over 2. Or x is 2 plus or minus the square root of negative 92 over 2. Or x is 2 plus or minus, we could factor out or pull out that square root of a negative is I, so I square root of 92 over 2. Okay, that will actually simplify. We could simplify it a little further. See, 92 divided by 4 is 23. So remember, simplifying radicals. 92 is 4 times 23. Square root of 4 is 2. So I could say 2 plus or minus I times 2 times square root of 23 over 2. Wow, this problem turned out to be much longer than I thought it was going to. I'm going to go halfway down the side of the page here. And then we're always allowed to split up fractions. I can't cancel the 2's here, but I can split this as 2 over 2 plus or minus 2i root 23 over 2. Cancel 2, cancel 2. And I get x is 1 plus or minus I root 23. Okay, yeah, that one turned out to be a little uglier than I expected. Okay, but there's... Okay, here, these two guys, we're solving using the square root property. We can only do that when I have junk squared equals a number. If there's not just a number over here, it won't work. That's what I have here. Something squared equals a number. Then I take the square root of both sides. I'm only allowed to do that if I put a plus or minus here on the right. On the left, square root of junk squared is just junk. Equals plus or minus square root of 25 is 5. Move the 2 over. X then is 2 plus or minus 5. That's two separate problems. 2 plus 5 is 7. 2 minus 5 is negative 3. Okay, very similar problem here, but this is not in the right form yet. It has to look like stuff squared equals a number. I have to make this 2 go to the other side first. Get x plus 3 squared equals, adding 2 to both sides, 17. Now it's stuff squared equals just a number. Square root of both sides. Don't forget the plus or minus. Square root of stuff squared is just stuff. On the other side, I can't do anything with square root of 17. Move the 3 over. X is negative 3 plus or minus root 17. Okay, this guy, solving by completing the square. First thing I want to do, divide by whatever is right here. That's a 1. Dividing by 1 won't change anything. Move the 10 to the other side. So x squared minus 6x plus blank equals positive 10 on the other side plus blank. Second step, look at this middle number, 6. Take half of it. Half of 6 is 3. That's not what goes in the blanks. Half of that squared. Half of 6 is 3. 3 squared is 9. The left side is going to factor. Whatever this variable is, whatever that sign is, if that was a plus, I would have a plus. And then half of this number, which is also the square root of this number, 3 squared. That's this entire left side factors like this. On the right, 10 plus 9 is 19. Hey, now this problem looks a lot like those problems we just did. It's junk squared equals a number. We can use the square root property. Take the square root of both sides. Don't forget your plus or minus. On the left, square root of junk squared is junk. I get x minus 3. On the right, square root of 19 I can't do anything with. And we move the 3 over. We get x is positive 3 plus or minus square root of 19. Okay, this problem. First thing we want to do, we're completing the square. Divide everything by this number. So we're going to divide everything by 3. We get x squared plus 4x minus 5 equals 0. Move the constant to the other side. X squared plus 4x plus blank equals 5 plus blank. We're going to be adding something in, so I like to put the blank. Take half of the middle number. Half of 4 is 2. Square it. 2 squared is 4. That's what goes in the blank. The left side now factors. X plus, because I have a plus right here, 2 squared. Where'd 2 come from? 2 is half of this middle number. It's also the square root of this last number. On the other side, 5 plus 4 is 9. Now we have stuff squared equals a number. We can take the square root of both sides. Don't forget your plus or minus. Square root of x plus 2 squared is just x plus 2. On the other side, square root of 9 is 3. So I get x plus 2 is plus or minus 3. Moving the 2 over, we'll get x is negative 2 plus or minus 3. Oh, a little off the screen here. Negative 2 plus or minus 3. Those are two separate problems here. Negative 2 plus 3 would be 1. Negative 2 minus 3 would be negative 5. By the way, if you solve a quadratic by completing the square, quadratic formula, whatever, and you get nice, pretty answers like this, whole number answers, and any answer that doesn't have a radical, that means you could have factored. If we look back up here, this would have factored. I didn't have to use completing the square. I mean, I did because the direction said to, but it could have been solved by factoring. Okay, now a couple of quadratic formula. You should have quadratic formula memorized now. X is opposite of b, plus or minus the square root. b, 5, squared is 25, minus 4 times a times c, all over twice a. So that's going to be negative 5 plus or minus square root. Okay, let's just do all this math. Order of operations. Negative 4 times 2 times negative 1 would be positive 8. 25 plus 8 would be 33. All over 2. Didn't really need all that square root bar there, did I? So we're done. We get x is negative 5 plus or minus root 33 over 2. That won't simplify. Okay, this guy, our last one. If I'm going to use quadratic formula, I have to be in standard form. I have to move this 2 to the other side first. If you don't have minus 2. If you don't have equal 0, you can't use quadratic formula. You have to be in standard form. Okay, then x is opposite of b. b is negative 5, so positive 5, plus or minus the square root of b squared, negative 5 squared. A negative times a negative is a positive, 25, minus 4 times a, another 4, times c, a negative 2, all over twice a is 4. Okay, let's just do all this math here. Order of operations, put that parenthesis there. Negative 4 times 4 would be negative 16, times negative 2 would be positive 32. So I've got 25 plus 32, which would be 57. Is that right? 25 plus 32? I think that's 57. So we get x equals 5 plus or minus the square root of 57 all over 2 times 4, 8. Okay, there we go. That's all of them.